If hyperspace were real, what dangers might lurk in the great unseen, and could it ever be more than a sci-fi dream? From wormholes to warp drives to hyperspace lanes, science fiction has given us imaginative ways to cheat the cosmos. But is any of it possible? And what is hyperspace anyway? Grab a drink, a snack, give the like and subscribe buttons a smack, and let's explore hyperspace. Hyperspace is a concept that bridges the gap between science and imagination, often serving as a stand-in for faster-than-light travel and speculative stories. Its presentation varies widely, appearing in major science fiction franchises like Star Wars, Isaac Asimov's Foundation series, and TV shows such as Babylon 5. At its core, hyperspace refers to an alternate dimension or higher dimensional space that allows travelers to bypass the normal constraints of our universe. Instead of being restrained by the cosmic speed limit, the speed of light, hyperspace offers a theoretical shortcut, enabling rapid journeys between distant points in the cosmos. While the term hyperspace doesn't have a direct and universal counterpart in current scientific models, it draws inspiration from real physics concepts, such as higher dimensions in string theory, wormholes, or the manipulation of space-time. Its interpretation in science fiction reflects as much narrative creativity as scientific plausibility. In science fiction, hyperspace is not just a tool for traveling faster than light, it's a rich narrative device that shapes the worlds and stories built around it. In Star Wars, hyperspace lanes offer established routes for interstellar travel, bottlenecks for trade, piracy, and battle. In Dune, the Spacing Guild's fold space ability allows instantaneous movement through a mysterious, navigationally demanding dimension. Meanwhile, Babylon 5 envisions hyperspace as a dangerous alternate realm where navigational beacons are essential to avoid getting lost, and ancient ruins drift in its void, waiting to be encountered by unwary or adventurous travelers. Ironically, Hyperspace from Isaac Asimov's Foundation, widely regarded as the top sci-fi book series of all time, is probably the least exciting. You engage the engine after performing the complex calculations, and disappear, and instantly re-emerge, hopefully at the right destination, but there's no passage of time or explanation for how the system works. I often recommend that approach to sci-fi writers. Don't waste time trying to explain a fantastic system whose only purpose is to get around the huge problem of getting around the huge immensity of space in human timescales. The earliest science fiction reference to hyperspace for FTL travel appears in Hugo Gernsback's Amazing Stories, circa 1931. However, the term itself predates modern sci-fi, tracing back to the 19th century, where it was used to describe higher dimensional spaces. This was before Einstein developed his theories of relativity, during a period when even some serious scientists speculated that stage magicians' tricks or complex knots might be exploiting four-dimensional space to function. They weren't thinking about it for space travel, though. In the early 20th century, science fiction didn't grapple much with the true scale of the universe. However, it wasn't until Edwin Hubble's work in the 1920s that humanity realized galaxies were distinct islands in a vastly wider universe and not particularly spherical islands either. I don't want to spend too much time explaining why we can't travel faster than light under normal circumstances. We've covered this in detail in our FTL, Faster Than Light series, but a quick overview is appropriate. The term light speed isn't the most accurate name for this universal limit. Light, along with all other massless particles, travels at this speed because they lack mass. Things with mass experience time. Massless particles, like photons, do not. As an object with mass accelerates, more of its total energy transitions from resting mass energy as described in ESRM-C2 into other forms, such as kinetic energy. You've probably heard that as you speed up, your mass appears to increase, meaning that every additional increment of speed requires more energy to accelerate further. This process continues exponentially, requiring infinite energy to reach the speed of light. Here's the key idea. At everyday speeds and conditions on Earth, nearly all the energy in objects exists as mass energy. For example, a glass of water contains an immense amount of mass energy, more than what is released in a typical atomic bomb, while only a tiny fraction of its energy is from thermal, kinetic, or gravitational potential sources. Faster-than-light travel would revolutionize our place in the universe. But are there ultimate scientific limits like FTL and hyperspace that even science cannot overcome? In the End of Science, our Nebula-exclusive episode, we ask whether science itself might have an end and barriers it can't not breach. Join us in The End of Science, available only on Nebula. Nebula is the largest creator-owned streaming platform, where every SFIA episode airs early and ad-free, alongside exclusive content from myself and many other fantastic creators like Real Engineering, Simon Clark, and Angela Collier. Sign up at https://go.nebula.tv/IsaacArthur, using my code IsaacArthur to get 40% off an annual plan. That is $3 a month. Nebula also offers lifetime memberships and gift options, and for new Nebula subscribers, you can get access to guest passes. Share your passion for Nebula with friends and family, and now let's warp back into the mysteries of hyperspace. Folding space generally assumes a different approach. Imagine folding a 2D map so that 2 points touch. In this case, the fold occurs through a higher dimension, our 3D universe. A fold space drive extends this concept, folding 3D space through an even higher dimension, or hyperspace, so that 2 points touch. However, how you jump between those points on the folded map is often unclear. There's also cosmological models in which this might be viable, like if string theory is right, in which case you not only have extra dimensions with many universes yet unlike our own in them, including different particles and physical constants, but interactions between those spaces. Indeed, it is assumed a collision or intersection of various branes can cause a Big Bang event, and something smaller scale should be possible too. It's also worth noting at this point that brane cosmology theory allows for a sort of higher dimensional area between universes, often called the bulk, which is an actual mathematical hyperspace. Conceptually, imagine you are a stick figure drawing on a piece of paper. You cannot survive without being on a piece of paper, you must be drawn on something. So if you want to fly to the other side of my office, I must fold the piece of paper you're on into a paper airplane and hurl you there. In Babylon 5, hyperspace is depicted as a separate dimension that allows for faster-than-light travel. Travel to and from various parts of the galaxy is done by first entering hyperspace, then leaving at the right place. Larger vessels, such as warships or capital ships, have built-in jump engines, which is handy for avoiding impossible military bottlenecks the jump gates would otherwise be, while smaller ships or civilian craft rely on pre-existing jump gates scattered across the galaxy. Hyperspace is a chaotic and unstable dimension filled with swirling energy fields, making navigation extremely challenging. Ships rely on beacons, navigation points that provide fixed coordinates, to plot courses through hyperspace. Without these beacons, navigation becomes virtually impossible, and ships risk becoming lost forever. Abandoned or derelict ships and ancient structures are known to drift in hyperspace, creating a sense of foreboding and danger for travelers, and shows up in both the spin-off series Crusade and the TV movie Third Space, where they find a relic floating in hyperspace that turns out to be a gateway to yet another realm beyond normal and hyperspace and full of murderous, telepathic, and xenocidal aliens. I should note the term non-Euclidean space gets used a lot in sci-fi on topics like this, and since we are a science show that uses sci-fi as examples, not a sci-fi lore channel as much as I enjoy that, I feel like I should explain that term as it gets abused a lot. Euclid is the Greek mathematician who gives us the 5 axioms of regular geometry, but it's not always arcane. For example, consider a set of train tracks, 2 rails that are parallel but seem to merge in the distance due to perspective. On a flat 2D map, these lines would remain parallel. However, if you folded the map at an angle, those 2 lines could cross. Another case involves spherical geometry. On a sphere like Earth, 2 parallel lines on a 2D map might appear to stay equidistant. However, on the actual 3D surface of the planet, these lines would form great circles, which eventually intersect. For instance, many video games create simulated universes with bizarre geometries. My 6-year-old son, whose name happens to be Geometry, recently started playing the old Dragon Quest games on Nintendo, or the tablet version. In those games, the 2D map allows players to sail east or west and emerge on the other side, which makes sense. However, sailing north or south does the same, meaning you reappear halfway around the planet without passing through a pole. This shows how non-Euclidean principles can be applied creatively, both in storytelling and in practical simulations, without requiring a full departure into incomprehensible madness. My other son, with the more mundane name of Chris, is currently obsessed with Star Wars, particularly